We are now getting into the logic of experiments and a lot of statistical concepts that are really interrelated with each other. So I want to do a simple demonstration that I hope will help you really get a handle on some of these concepts. So let me show you real quick just a list of some of the things that we're going to cover. So let me just quickly put a PowerPoint up here for you guys to see for a second. Of course, logic of experiments, effect size, that is how big of an impact does the independent variable have on the dependent variable? How big a difference does it make? Error in any kind of measurement. This is our dependent variable that we're thinking about. How sample size comes into it. Type 1, type 2 errors. Power is the ability to reject the null. Power is your ability to find a statistically significant difference. So what I want to show you here is I have a plate full of participants. Okay, these are just people that I've recruited or they signed up for my study, and you can see they come in all shapes and sizes. And you know, this guy is kind of tall, and this guy is a little bit wider. This is this really sweet girl that signed up. And I'm going to randomly assign them into my two groups. So I have two groups in my study, and let's say I flip a coin for each one, and I go, okay, here you guys go. And we're mixing them up, and I get 6 people in each of my groups. Okay, so now at the beginning of any experiment, once I've randomly assigned my participants to groups, at this point, the groups are roughly equivalent. Now, they're not perfectly equivalent because if I were to measure something about them, let's say for this, my dependent variable is weight of the cup. Well, they are not going to weigh exactly the same, obviously, because there's individual differences. The participants in here weigh a little more, a little less than each other. But if I took the average of the cups, you know, given enough participants, we're going to have some heavy people, some light people, everybody in between in each cup. Because by chance, since if we have enough people randomly assigned, then by chance, we're not going to get all the heavy people in one cup and all the light people in another. That might happen if we have some kind of biased sampling or biased assignment procedure, but random, if it's truly random, then it should all work out in the end. Now, if a small sample size, this is only 6 and 6, it could be that just by chance, the heavy people end up in one and the light people in the other. But if I have 20, 30, 50 people per group, then random assignment really controls for all of those individual differences. There's no reason to expect that some trait that's related to my dependent variable is going to end up all in one cup. So that's why random assignment is really important. So I start off with roughly equivalent cups. Okay. Now, in the experiment, now I'm going to do something different to them. I'm going to apply the treatment or the independent variable. So maybe I'm going to do something to one group and not the other. This is going to be a real control group, and I'm going to do something to these guys. Now, I'm going to represent my independent variable with this roll of dimes. And now this is a pretty big roll of dimes. So if I do something to this group and not the other, I have now made them pretty different. I can really detect an effect here. This independent variable would have, if I have a big effect size, the IV has a big impact, I'm really going to see that in my dependent variable, in my measure. I can really detect this. Now, think about it. I'm trying to detect the effect of this IV against the background noise of these individual differences. So for weight, I'm trying to detect the difference in the weight here against the already small differences in weight that were in my cups to begin with. Now, if I have a big effect size, that's really easy. Oh yeah, I can tell a difference. Let's say my IV was not something that had such a big impact, but it was something just had a little tiny impact, this penny. I go, these don't really seem very different. What I'm experiencing right now would actually be called what is a type 2 error. I did do something different to these cups. This cup should be heavier, but if my dependent variable is not sensitive enough to detect that tiny little impact, that tiny little effect size, well, that little change I made, I'm going to miss it. It's not really in there. It's just going to be eaten up by the background variation in my groups. Okay, so that's what a type 2 error would be, and that essentially tells you what an effect size would be. Now let's think about some of the other words I had at the beginning. Let me take my IV out here. Okay. Remember that analogy of background noise. Okay, that's really important. I start off with individual differences or random error that makes these cups not exactly the same. And again, then I have to apply my treatment. So this could be, I give, you know, by now we may have done the experiment where I give each group different instructions on a list of words. So let's say I'm going to show everybody a list of words. But this group, I say, when you hear the words, decide whether or not the word has the letter E in it. And then this group, I say, when you hear the words, and these guys don't know it, when you hear the words, visualize the word and decide whether or not you like the word. Okay, and just do that. So then they all come back. I say the words, then we have a delay, we hang out, and then I test the memory of the words. Well, this group who was cognitively doing more should have better memory because that has a big impact, right? So the IV, the difference in instructions that I gave my two groups, it does change memory. Now, all these other things are going to give them different memory scores too. Like some people in both cups have good memories, bad memories. Some are sleepy. Some had caffeine. Some were practicing the words in their head even though they probably shouldn't have. Some were paying attention or not paying attention. All that stuff is individual differences that put random error in my data. But I want to see if the effect of the independent variable can still be detected in addition to that random error. You know, it's like the background noise is like a radio static, and the signal that the radio signal, the song I'm trying to hear against the background static, is the effect of the IV. All right. Let's talk back again. You know, look, I have all these different kinds of people in here. What if I tried to get very similar kinds of people to be in my study? I was really picky. I said, you know what, there's too much, you know, individual variation, there's too much noise in my data. Let me get just people that are all really similar. So I'm going to get all, I don't know, 22-year-old white females that went to public high school in Farragut, Tennessee, and they all go to church and play flute in the band, and they have very similar beliefs and attitudes and all that. If I got people that were very, very similar to each other to be in my study, and I randomly assigned them to my cups, so I had basically 2 cups of Lifesavers, I would have much less random error, right, in my groups, and it would make it easier to detect a small change. Okay. Now, as you can appreciate, though, the more homogeneous my sample is, well, that's going to decrease my external validity, meaning, well, okay, I figured something out about my people, but who does it generalize to? Oh, well, these guys are all very similar. Now, of course, people aren't that similar, so that makes life more interesting. But as you relax the criteria on who can be in your study, so some studies will say we want people between ages of 20 and 25. Well, if I instead took people from age 20 to 70, I'm going to have more individual differences, right? And it really depends on what I'm studying as to how narrow I want my criteria to be and how much, you know, the more relaxed I am, the more differences I start out with, well, then I have much better external validity. That wasn't even on our list of terms, was it? Sorry. All right, so effect size is a really big idea for this demo. We have, you know, an IV could have a big effect size, an IV could have a small effect size. We don't often have a lot of control over the impact of the IV. For example, when the memory demonstration where each group got different instructions, well, those instructions are going to do whatever they do. Now, sometimes we do have control. So if I was running a drug study and I had a new drug and I said, okay, the control group's going to get 0, and then one group's going to get 100 milligrams, and then I'm going to have a third group and I'm going to give them 102 milligrams of drug. Well, that's stupid. You would never do that because you don't think there's really going to be a difference. But you might have 0 milligrams, 100 milligrams, 1,000 milligrams. Okay, I'm trying to basically create a bigger effect size. I want to see a difference between my groups. So sometimes we do have a little bit of control over that. If I want to measure something about people studying, and I say, okay, I'm going to have one group that doesn't get to study the material at all, one group that gets to study for an hour, and another group that gets to study for an hour and 10 minutes. Well, that's not going to make a difference in my measure of how they do on a test. So I can say, okay, you get 0, you get an hour of study time, you get 3 hours of study time. Okay, now I should probably see a difference in the number of answers you get correct on this test over the material. Okay, so we have a little bit of control over effect size, but at some point it is what it is. Power. The bigger your effect size, the easier it is to see a difference. Well, that's basically the definition of power. So if it's easy for me to detect this big thing, I just put in there, I have power. I can reject my null because I can detect the difference. All right, so when we have a small effect size, we said that there's a risk of a type 2 error. There might actually be something that happened here that I just can't detect. Type 1 errors, let's just forget about that for right now. But what I really want you to take home with this is appreciating the background random error, the idea that the effect size of the IV is kind of laid on top of that. Having a big effect size does give us power. What else? Sample size. The bigger your sample size, the less I'm worried about these individual differences. They really are going to get taken care of through random assignment. That should do it for now. So hopefully this helps you on some of those concepts.